Welcome everyone to session 1E. Today's topic is the intermediate value theorem. As mentioned in the last video, the intermediate value theorem is the first concept that appears directly in the FRQs as part of the key steps. So suppose we have some continuous function f, and we have these 2 points at x equals a and x equals b with their corresponding f values. Now, suppose I choose some k between f of a and f of b. So if we choose some k in the open interval from f of b to f of a. Of course, in this case, it's specifically that f of b is smaller than f of a. Sometimes it's the opposite case. Now, I'm going to pull a line of y equals k. And I'm going to ask myself if this function must pass through or intersect this horizontal line. And what the intermediate value theorem says is yes, it guarantees that there is at least one number c between f of a and b such that f of c equals k. So in mathematical terms, what the IVT says is this means there exists some number between a and b such that f of c equals k, where k is between f of a and f of b, or the other way around. It could also be this. So this is what the intermediate value theorem states. It says that if we have 2 points and we have some horizontal line between them, or like some y value between them, the function, the continuous function, must pass through that line or pass through that y. So let's look at this in use. Here we want to show that there exists a positive number exactly one less than its cube. So we want a positive number x that's exactly one less than its cube. And what we're going to do is we're going to move everything to the right-hand side, and we're going to call what's on the right f of x. So we have this, and we wish to show that there exists some value of x so that this function evaluates to 0. So what we're going to do is we're going to try a couple values. So we're first going to do f of 1. F of 1 evaluates to 1 minus 1 minus 1, that's negative 1. And f of 2 evaluates to 8 minus 2 minus 1, so that's 5. Now, notice that f of x is a continuous function. It's a polynomial. And we have f of 1 being negative, so this is less than 0, and f of 2 is positive. This is greater than 0. So what we are going to reason with is the following. We're going to go like f of x is continuous. And we're also going to say f of 1 is equal to negative 1 is less than 0, and this is less than 5, and this is equal to f of 2. Given these two properties, the intermediate value theorem tells us that there exists some c between 1 and 2 such that f of c equals 0. And we claim that this c is the positive number that we're trying to find. Notice this c is a positive number, and it satisfies this f of c equals 0. And when f of c is equal to 0, or when this f of x is equal to 0, we have that this desired statement is true. So we have shown using the intermediate value theorem that there must exist this positive number c. So we're going to move on to some actual AP questions. This was an MCQ from one of the APs. And so we have a function g as well as its value at negative 1 and 2. And we want to find which of these conditions guarantees that there is an x between negative 1 and 2 for which x equals 3. So what we are given, let me just briefly sketch, we are given g at negative 1 is 0, and at 2 is equal to 5. So we're given these 2 points. And we want to know which condition guarantees that there's an x for which g of x is equal to 3. So it's roughly somewhere in the middle. And this is exactly what the intermediate value theorem would guarantee. And the condition that is required for us to apply this theorem would be that g is continuous, which is this option over here. You could easily rebut all the other ones. For example, g is defined for all x. That is certainly not true, because you can just, it could literally be something like this, and then you have a removable discontinuity, or if it's just increasing, we could go something like this and suddenly do a jump. So there are a lot of ways to think about eliminating the other ones, but pretty much it's very immediately obvious that this is about the intermediate value theorem. So here we have our first FRQ. An ice sculpture melts according to some function, and the radius is given by this r. And the table gives selected values for r prime. For now, we did not talk about differentiation or notations yet, but you can assume that this is some general function. And twice differentiable would imply that this r prime is continuous. Again, you don't have to know this. I'm just giving you this information for the sake of learning the IVT. So we know that r prime is continuous, and we know what r prime, we know some values of r prime. Now, the question is, this is one of the 3 or 4 small questions. Is there a time t between 0 and 3 for which r prime t is equal to -6? Now, to answer this question in an FRQ, in general, there are 2 big steps that you have to follow. The first is that you gotta set up the relationship between this -6 and the ones that you're comparing it to. So here we care about 0 and 3. So we're going to compare it to their r prime value. So what you're going to write is you're going to write r prime 3 is equal to -5. Oh, actually, r prime 0 is equal to -6.1. And this is less than -6, and this is less than -5.0, which is equal to r prime of 3. So we have established that 6 is between 2 function values that are highly relevant here. So for that year, this would have earned you 1 point. You're going to assert that r prime is continuous. Here, we're first going to pretend that this is given to you. So you're going to write, because r prime is continuous, the intermediate value theorem, and try not to be lazy here because this sometimes it's just better to write it out. The intermediate value theorem guarantees a t with t between 0 and 3 where r prime of t equals -6. So this, writing this continuous part, naming the intermediate value theorem, and ending up with a conclusion together would earn you this second point. So notice, even though the mark schemes are different every year, if you follow these steps on all of this type of FRQ, then you would almost certainly earn all the points that are to be given there. So this first, you set up a comparison, and second of all, you assert continuity, and then third of all, you name the intermediate value theorem, and fourth of all, you talk about the conclusion. So this is a nice series of steps that you can follow, and we're going to use it again right over here. So here we have water is pumped into a tank for for t between 0 and 8. Is there a time when the rate at which the water is pumped into the tank is the same as the rate at which water is removed from the tank? Basically, what this question is asking is, we're given this r, some values of r, and the exact function of w, and we're asked, is there a point where these two functions are equal? So more specifically, the rate at which water is pumped into the tank is given by w, and the rate at which water is removed is given by r. So we want these two to be equal at some t. And in general, for questions like this on the AP, is there a time t? It usually hints at that there is. And so the hard part is about justifying it. And usually we do that with the intermediate value theorem. So what we're actually going to do is, because we know less information about r, we're going to sort of find some information about w that is parallel to this r. So we want to figure out what w of 0 is, what w of 1 is, and what w of 3, 6, and 8 are. So we can have sort of this parallel comparison. So using a graphing calculator, you can find these values. And so given these values, we notice this very special interval from 3 to 6, because when we have t equals 3, w is greater than r, But when t equals 6, we have r is greater than w. So what we are going to do is we're going to construct this function f. We're going to construct f of t is equal to, let's say, wt minus r of t. And when f of t is equal to 0, like in that function, we have when f of t is equal to 0, then we have that f of t equals r of t, which is exactly what we want. So what we're going to notice here is that we're going to have that f of 3 is equal to positive 325, and f of 6 is equal to this minus this, and that's going to be negative 409. So here we're going to set up a comparison again. So we're going to have f of 6 is equal to negative 409. This is less than 0, and this is less than 325, and this is less than f of 3. So first of all, again, we set up this comparison. Then we're going to assert that f is continuous. F is continuous. And as covered, we know that a difference of continuous functions is continuous, and we know that w is continuous here, and r is differentiable, and later we would know that this means continuous. So f is continuous because it's a difference of two continuous functions. So this we have shown. So we're going to say because f is continuous, we apply the intermediate value theorem, the IVT. It guarantees that there exists some t between 3 to 6 where f of t is equal to 0. And at that point, we have this desired equation. So here, again, we have done these 4 steps, despite that the setup was a little bit more difficult. So it's still these 4 steps, but here, because this question is a little bit harder, we needed like a bigger setup and some more calculation. And these are pretty much all the examples for today's video. We'll be doing more questions in the practice session. And this is everything for Unit 1. Thank you, everyone.